This is GATE 2016 Set 2 EC question number 54. A microwave circuit consisting of lossless transmission lines T1 and T2 is shown in the figure. The plot shows the magnitude of input reflection coefficient gamma as a function of frequency. So the phase velocity of the signal in the transmission line is 2 into 10 to the power 8 meter per second. Now useful data you will need in order to solve this question is the reflection coefficient magnitude equal to ZL minus Z naught divided by Z naught plus ZL. So ZL is the impedance seen on load side, Z naught is the characteristic impedance. Now also beta is 2 pi by lambda. Beta is the phase constant, like propagation constant, gamma is alpha plus j beta. So this is the attenuation constant, this is the phase constant, right? This is phase constant and this beta is here and it is 2 pi by lambda, where lambda is the wavelength. In order to solve this question, first see this graph of mod gamma, where you can see that at 1 gigahertz it is 0. So coming to the solution, mod gamma equal to ZL minus Z naught mod whole over ZL plus Z naught plus ZL whole mod equal to 0 at 1 gigahertz, right? So at f equal to 1 gigahertz, okay, implies ZL equal to Z naught. This is we are talking at 1 gigahertz frequency. Now you see we are drawing a simplified version of this transmission line. See this diagram in the given question. This first section of the transmission line is cascaded with the second section of the transmission line where this resistance. So like draw this L equal to 1 meter and this length we don't know. So both are cascaded, right? And this is L, let's say L2. Now it is grounded and here is the 50 ohm resistance and it is open circuited. And Z naught equal to 50 ohm. Now this is ZL, you see from here. In the question Z02 is given as 50 ohm and Z01 for this line is given as 50 ohm also. Just see the problem, both are 50 and a 50 is connected here also. So ZL is 50 parallel impedance of line 2 equal to 50 parallel impedance seen by line 2 input. So this line will have an impedance of, as seen from the input side, as like this at this side as minus Z02 cot beta L, beta L2, because L2 is the line length, right? So you just put this here because 50 is there, so 50 parallel with this input impedance seen from here for line 2, so minus JZ02 cot beta L2 equal to 50 parallel minus J50 cot beta L2. Now coming to the solution, ZL is 50 parallel minus J50 cot beta L2. Z0 is 50, so ZL minus Z0 by ZL plus Z0, which is gamma mod gamma equal to 0 at 1 gigahertz. So this is possible. Z0 equal to Z0 should be right. Now ZL equal to 50 parallel minus J50 cot beta L2. This should be equal to Z0, which is 50. Now our resistance parallel with some resistance is same as that resistance. When is that possible? When this resistance is very huge, right? So minus J50 cot beta L2 must be equal to infinity. This concept is clear, I think, because you see R1 and R2. If I say you R equivalent equal to R1 R2 plus by R1 plus R2, now I say you R equivalent is also R1. So when this is possible, when R2 tends to infinity, you see put infinity here, R2 tends to infinity, you can write like this: R1 divided by divide by R2 of numerator and denominator, you will get R1 by R2 plus 1, which is equal to R1, because this will go to 0 because R2 tends to infinity. So when the parallel combination of two resistances are giving you one of the value of the resistance only, the other one must be tending to infinity, that is very huge. So minus J50 cot beta L2 must be infinity in order to satisfy this condition. Now if this is so, then cot beta L can be written as infinity. So beta L must be equal to n pi, because what is cot? Cot is the theta. Cot theta is cos theta by sin theta, and cot theta will tend to infinity only when sin theta will tend to 0, and sin theta tends to 0. You can see here in this circle, when it is 0, it is 0 at 0, theta equal to 0, then theta equal to, just see the y shadow. So here if it is here, then the y shadow is 0, projection, that is y projection 0, then again here which is pi, then again when it is 2 pi, then again when it is 3 pi, then again it is 4 pi. So it is like this. So integral multiples of pi, so that's why it is coming. So beta L must be n pi, then only it will be infinity, that is cot beta L will be infinity, will be satisfied. So now if this is the case, beta, this is 2 pi by lambda multiplied by L, actually L is L2, so L2 equal to n pi. For n equal to 1, pi lambda by 2 pi equal to L2, pi gets cancelled, equal to lambda by 2. So I can find lambda. So you know the wave velocity and wavelength is lambda, and f means f waves in 1 second. So if in 1 second f waves means f lambda, distance, right, because f is the frequency, so in 1 second f number of waves will pass. So f number of waves means f lambda distance, because one wave means lambda distance. So this distance the wave can cover in 1 second. So this is the nothing but the velocity or the wave speed, that is v. The wave speed is f lambda. So lambda equal to v by f, and this is 2, v by 2f. So v is given as 2 into 10 to the power 8. You see in the problem The value of v is given 2 into 10 to the power 8. Phase velocity is given divided by 2 into frequency is 1 gigahertz, 1 into 10 to the power 9, which is 0.1 meters. So length of the second section of the transmission line is 0.1 meters. So answer will be 0.1 meter.